Hello, this is Memphis Communiversity. Today we are going to be practicing AP Calculus Fourier response questions, and today we are doing a very common Fourier response question that appears on both the AB and the BC versions of the AP exam, and that is, of course, table Fourier response questions. So I usually refer to table Fourier response questions if there's obviously a table and there's some sort of situation. As you'll see, sometimes the situation will be particle motion, but in this case, what we're going to do is we're going to have 10 videos, one for each difficulty from 1 to 10, and we go from the easiest level to the hardest level. So this is going to be the introduction, so there shouldn't be anything too bad about this. And you'll see that as we practice these table Fourier response questions, a lot of things sort of repeat themselves, like approximating derivatives, MVT, IVT, and Riemann sum. So those are the big things that appear on a lot of these sort of practice questions. We do this for every single Fourier response question topic, so table Fourier response questions, area and volume, BC stuff like Taylor series. But let's get started with this one because it is a very important Fourier response question. It does appear quite a bit of times, and it's not the hardest Fourier response question, as you will see. So let's practice. So looks like I have my friend here, Castle. Castle likes to doodle things in her little notebook. And it looks like the number of doodles, see if you can see this is the word doodles, is given by this function d. And nothing too major about it. D is in doodles and t is in minutes. Sometimes that helps with the units. And it does say this sentence right here, dt is a strictly increasing function. We'll see where that comes up later. But for now, we're going to do a pretty easy question, which is use the data in the table to approximate d prime. D prime, of course, being the derivative. But we're not taking the derivative, of course, because it's the approximation. So the derivative is calculus slope. In order to approximate it, what we're going to do is we are going to be doing algebra slope. So how you do that is you look for which pair of columns does 4 appear in the middle of, and it's going to be these two right here. So basically we're doing algebra slope on these pair of columns, or this pair of columns, y2 minus y1 over x2 minus x1. So if you want, you can write d of 5 minus d of 3 over 5 minus 3. So again, very easy question. This question appears oftentimes in part A of these Fourier response questions, just doing algebra slope, since you've been doing since your algebra 1 days or maybe before then. So it's just going to be 7 minus 2 over 5 minus 3. 7 minus 2 over 5 minus 3 is equal to 5 halves. So that is my approximation. It does ask me to indicate the units of measure. So whenever the AP exam asks me to put units, I'd put them. And if they don't, I don't. But I do note that they do in this case. So whenever you're taking a derivative, you just divide by time, sort of like how particle motion goes from meters to meters per second to meters per second squared as you take derivatives. So in this case, we're going to start off with doodles. If you can see that, that's the word doodles. And we're going to divide by our time period, which is minutes. So it's the doodles per minute. Then sometimes they ask you to interpret this. So if ever a derivative is positive, that means that whatever it is, so the amount of doodles will be increasing at this rate at time is equal to 4. So that'd be the interpretation if they had asked that. But again, a very easy question. You'll see that these will appear in later examples as well. So be on the lookout for that. So the next question is says that is there a time t such that d prime of t equals 1? So even when I read the words is there a time, I know that it's either MVT or IVT. How do I know that? Well, MVT or IVT are existence theorems in calculus. They don't ever tell you the numbers. So most questions are things like find a time, take the integral, take the limit, take the derivative, where all these things are going to be numbers. But for MVT, IVT, they're just existence theorems, so they just show you that a time exists. So the wording of these questions are a little bit weirder. Is there a time t? Why must this exist? What's the fewest number of times this must happen? Show that this must happen, that sort of wording. Then you know it's MVT or IVT before you even read the question. And so when you determine that it's MVT or IVT, what you want to do, of course, is determine which one should I use. Should I use MVT or should I use IVT? And the general rule of thumb is that if there's a derivative of the function that's given, you're probably going to be doing MVT, because MVT, the phrase to remember for MVT is calculus slope equals algebra slope somewhere in the interval. If this were DT, I would probably be trying to use IVT if possible. In this case, it would not be possible because 1 is not in between 7 and 12 there. So in this case, because it's prime, it is definitely MVT. If you want, you can check out our videos on MVT or IVT. Hopefully they will be on the channel by the time you watch this. We have videos on all calculus topics. But for now, let's do MVT. So how I like to do is MVT is I like to write by MVT or by IVT. So in this case, it's by MVT. Then I'm going to put my work here. And the work for MVT is pretty simple. All we're going to do is we're going to be doing algebra slope. So we're going to be doing algebra slope on this interval right here, 5 to 10. Keep in mind that usually it is the interval that they give you. But if they give you the entire interval, sometimes in trickier questions, as you'll see later as we progress in these difficulty videos, you have to eyeball two appropriate columns that give you that slope. But in this case, I am going to be using the slopes 5 to 10. Just try to check out some algebra slopes between different columns if the need arises. So in this case, we're just going to do algebra slope, sort of how we did in the first one. So it's going to be d of 10 minus d of 5 over 10 minus 5. So we have 10 and 5 here. So it's going to be 10 and 5. So it's going to be 12 minus 7. And remember that when you're doing MVT, you want the slope to be exactly the number they want. It's not like IVT where you're showing a y values in between other y values. So in this case, we do get 1, which is great because, of course, they want us to get 1. So we are done with the work. And then finally, what I like to do is, again, the questions are worded weird. So I just like to change their weirdly worded questions to be a statement. So I'm just going to say by MVT, there is a time. And I'm basically repeating what they said. So is there a time? There is a time. Where the time interval is between 5 and 10, because those are the t values that we use, such that d prime of 10 t, is equal to 1. And that is MVT. Let me just say an example of IVT just for your benefit. So let's say we had these two columns where we had t between 0 and 3. And we said, why must there be a time where d of t is equal to 1/2? That would be IVT, because 1/2 is in between the y values of 0 and 3. Y values, so 1/2 would be in between d of 0, which is 0, d of 3, which is 2. So it would be true by IVT. So that's how IVT works. Again, if you continue watching these this video series, we'll do some examples of IVT, of course. So that's the first half of this first month's question practice. Nothing too bad. Both questions actually, by coincidence, required some sort of algebra slope, because MVT has the phrase calculus slope equals algebra slope, and when you approximate derivatives, you're finding algebra slope. Algebra slope is also the average rate of change. So while calculus slope is, of course, more common on the calculus exam, it seems like average rate does appear every once in a while. So let's do the next question. The next question is a Riemann sum question. It looks like it's going to be a right Riemann sum question. And then finally, there is some other sentence that we have to consider after we do the Riemann sum. So keep in mind that there's 4 types of Riemann sums. There's left, right, trapezoidal, and midpoint. And if you watch our first 4 videos, it's going to be alternating. So every single one of those questions has a Riemann sum question in it. And one of them is going to be right, one of them is going to be left, one of them is going to be trap, and then one of them is going to be midpoint. Trap meaning trapezoidal. Also, if you want just a video on Riemann sums, we do have that, of course, on our channel. But let's see how Riemann sums work. So basically, how I like to do this is I like to tell my students to draw this little thing right here. I don't know what they actually are, but basically, we're just saying we're going to take this pair of columns, then we're going to take this pair of columns, this pair of columns, and then this pair of columns. So every single adjacent pair of columns. And then what I want you to know is it's always the difference in the x's or the t's in this case. So it's always going to be 3 minus 0 times a different number. So let me just repeat that. So when you're doing Riemann sums, I don't actually draw the rectangles anymore. I just look at tables because these table questions are so common. But the base of the rectangle is going to be 3 minus 0, no matter if you're doing left, right, trap, or midpoint. Then, if you're doing left, you would choose the left number, left y value as your height of the rectangle, so that'd be 0. If you were doing right, you would choose the right endpoint. And then if you're doing trapezoidal, you would do the average of these two. So again, it would be 3 times 0 if it was left, 3 times 2 if it was right, and then 3 times 0 plus 2 divided by 2 if it was trapezoidal. Midpoint's a little bit weird because you do need some sort of midpoint value given, and midpoint values are not given in this table. So yeah, it's always, but notice when I said, when I listed out left, right, and trapezoidal, it was always the difference in the x's. Always, or in this case, t's. Always 3 times something. 3 times 0 for left, 3 times 2 for right, 3 times 0 plus 2 divided by 2 for trapezoidal. So let's do this. I will have to keep flipping back and forth, so hopefully you do not mind. But let's write this. So we're going to write this integral out. Remember that Riemann sums are not actual values of the integral, but they approximate the integral. Basically, they're approximating area as instead of finding the exact area. So let's do right. So the first Riemann sum was going to be, again, 3, the difference between these two numbers, times 2. So it's going to be 3 times 2. Then it's going to be the difference of these two numbers, which is 2. If we were doing left, we would choose 2, but we're doing right, so we're going to choose 7. So it's going to be 2 times 7. And then 8 minus 5 times 11. 3, the difference in the t's, times the right y value of this pair. So it's 3 times 11. And then finally, we have one last one. 10 minus 8 is 2. If we would have done left, we would have chosen 11. If we would have chosen, but we're choosing right, so we're going to choose 12. So it's going to be 2 times 12. And then we're going to add these up. It's going to be 6 plus 9 plus 33 plus, I believe, 24 here. Again, we're going to add this up. Looks like 6 plus 24 is 30. 30 plus 33 is 63. And then finally, 63 plus 9 is 72. So this is the answer for the first part of the question, just doing the right Riemann sum. Again, before the AP exam, I encourage you to know how to do left, right, trapezoidal, and midpoint. You never know which one it is. They are asked equally often. Watch our videos if you want more explanations. But a lot of my students end up liking Riemann sums because notice you're just multiplying and adding numbers basically. And the hard part is just determining whether which numbers to multiply and add. But if you keep with my rule, it's always the difference in the x's times different y's. You should be good. But this question does ask a follow-up question. So what I tell my students is oftentimes in the Riemann sum question, the Riemann sum is not the answer. So for example, the question could be find the Riemann sum, and then it asks an additional thing. So in this case, it's approximate overestimate, but I've seen things where they ask you to find the average, and remember the average is 1 over b minus a, the integral of this, for example, d here. So the average would not be this. We would have to do one more step and divide by the length of this interval, 1 divided by 10. So it'd be 72 over 10. So keep in mind that sometimes you have to do additional steps. The Riemann sum is just the approximation. Same thing that I've seen on certain questions like these, that they ask you to do fundamental theorem of calculus to approximate the antiderivative at a value. So the integral and the Riemann sum will just be the integral, of course. So then you would have to add the initial, which will be given. And we have practice of these as well. But in this case, we have whether the approximation is an overestimate or an underestimate. So it's based off this word right here, right, and also increasing. So there's actually only 4 cases when you do the overestimate, underestimate, left, right. It's either right increasing, right decreasing, left increasing, left decreasing. We might as well write all of them right here because we do have some time. So I'm going to write left increasing, left decreasing. So again, these are all givens. The fact they asked you to choose a certain Riemann sum, either left or right, when they do this question. And then if you look in the values in the table, either they're increasing, and also that it says it's a strictly increasing function, or it would be a decreasing, of course. So you don't have to answer all 4, obviously, but I just wanted to illustrate the purposes of how to do this. So anytime you have an increasing function, you can draw any increasing function. It doesn't matter if it's concave up or down. left decreasing, you want to just draw any decreasing function. And then what you do is you draw a little number line here, fix an interval. So you can call it AB. You don't need to call it anything if you don't want to. So a left sum, remember, looks like where you take the left point of the interval and you go up to the curve. So in this case, it is up right here. And notice in this case, left rectangle will be under. Over here, again, we draw a little number line. We draw an interval. We go to the left one, the left endpoint of the interval, go up to the function. That's going to be how tall our rectangle is. So we're going to draw a straight line parallel to the x-axis. And notice in this case, it is an overestimate. Now we're going to do right decreasing because we'll save the actual question for last. So we're going to fix an interval. That wasn't great because we need to go to the right endpoint this time. So it's going to be this, and it's going to be this tall. So don't mind this little thing right here. That's not part of the picture. But again, for a right sum, you take the right endpoint of your whatever interval you draw, go up to the function, and that's how tall the rectangle is. Notice in this case, it will be under the curve, so it's an underestimate. Basically, it's underestimating the area under this curve because it doesn't include this part right here. And then finally, right increasing, what the actual question is. Well, we're going to fix a and b like normal, and we're going to take the right endpoint, go up to the function. That's how tall my rectangle is, and notice that it's over. So I tell my students not to memorize this. Some of them do because there's only 4 of them, but it's pretty easy to replicate these pictures. Again, for increasing, decreasing, you just draw any increasing or decreasing function. For left, the left endpoint determines the y value. For right, the right endpoint determines the y value, and then you just have to see how tall each one is. So it's not too bad of a question. In this case, we are dealing with right and I believe right and increasing. So we are going to write because I don't even know why I wrote because right Riemann sums it looks like it's going to be overestimate increasing functions. And that's just my justification if I needed to. Looks like I did not need this because, so I'll just mark it out. But right Riemann sums overestimate increasing functions. For example, left Riemann sums overestimate decreasing functions. Again, it's one of these 4 cases. So hopefully that makes sense. So again, when I want to stress in the Riemann sum question, which is this one right here, they appear in most table questions. I used to call these questions actually Riemann sum questions because they appeared, but I changed the name to table free response questions because the Riemann sum really doesn't have anything to do with the rest of the question, but they are important questions. So keep in mind, there are 2 big things. You want to know how to do left, right, trapezoidal midpoint, and that's always the difference in the top row or the x or the t row times different y's. And then just make sure that the Riemann sum is not actually the answer that they want. You might take the Riemann sum and do something with it. Either divide by time for average, add the initial for fundamental theorem of calculus, or maybe determine some sort of overestimate, underestimate thing. Eventually, we'll have particle motion questions that are mixed in with these tables. So basically, this row right here will be velocity. And oftentimes, they'll have approximating an integral with the absolute value of velocity. And they ask you to interpret, that's total distance. So if you want to see that, that's in our next video, actually, difficulty number 2. We have one last question to do. And oftentimes, for this last part, the last 3 questions are very common in these free response questions. Approximating a derivative, doing MBT or IBT, and then doing Riemann sums in these table free response questions. The last one is usually some sort of random thing. It will either be fundamental theorem of calculus with a new function, a derivative, which is in this case, maybe a related rate, something like that. Maybe they also ask you to interpret other things as well. But in this case, we are just taking a derivative because it says the amount of notebooks, doodles in her notebook. This is still Castle. She draws lovely doodles in her notebook. It says it's modeled by this function now instead of the table when you have 10 to 12. And then what we're going to do is we're going to find the rate. Rate means derivative, of course, so all we have to do is take a derivative. We don't have a calculator, but it should be not too bad. So all we're going to do is take a derivative here. If you did have a calculator, of course, use your calculator. I encourage my students, even in the Riemann sum, where you're just adding and multiplying numbers, if they give you a calculator, you might as well use it. But in this case, it was no calculator. So we have one last thing to do. Let's just take this derivative. And if you're taking derivatives, of course, be wary that you might use the chain rule. In this case, we will, because there's an inside function here. So it's going to be 2 times 2t minus 19. This is the power rule. We took the 2, dropped it to the front, and then we subtracted 1. And then finally, we have to multiply by the derivative of the inside function that happens to be 2. Then all we're going to do is plug in 11 and see what we get. So it's going to be c prime of 11. How exciting. 2 times, we'll do all the math later because I'm not confident right now. So it looks like it's going to be 2 times 2, which is 4. 22, 2 times 11, 22, minus 19, that's 2. So it looks like it's going to be 8, and that is the answer. Again, they didn't ask me units, so I didn't put units, but this is not a very high stress environment. Let's just try to think of the units if we were to ask. Well, all of these things are in doodles. All these functions are in doodles. So again, whenever you find a rate, either the average rate, which is the algebra slope, or the derivative, the instantaneous rate at a number. Oh, my sort of phone went kind of weird there. Let me autofocus it. Anytime you're taking any sort of rate, algebra rate, slope, or calculus slope, what you're going to be doing is you're going to be dividing by time for the unit. So it's going to be doodles per minute. And that is this free response question. Again, one of the easier free response questions, especially at this level. We are starting sort of at the basic level, but what I wanted you to see is I wanted you to see examples of the big main questions that are asked in this free response questions. Those being here, approximating a derivative, doing MVT or IVT, and then finding a Riemann sum. In this case, it was one of the easier Riemann sums. It was right. And also that the additional question wasn't too bad because you can sort of expect it. There's only 4 possibilities that they can ask, just like there's 4 possibilities of Riemann sums that they can ask. Finally, this last question was pretty easy because it would just involve taking a derivative, which was just this. We used the chain rule, of course. So that's it for this first video. I encourage you to continue watching these videos. For example, in our next video, difficulty number 2, it's going to be similar to this, but everything is going to be particle motion related. So that might require knowing the particle motion rules. I did say that it will be an integral of the absolute value of velocity or the integral of speed. That's going to be total distance. So if you want to practice one with particle motion, then be my guest, and I would certainly love it if you would participate with us, because we do enjoy hanging out with you guys. We want you guys to improve. And one of the best free response questions to improve on is the table free response question, because it appears so often. But until then, thanks again for watching, and goodbye.